Today we're looking at the derivatives of natural logs. Last video we looked at was the derivatives of exponentials, and a lot of times, just like exponentials with natural logs, you're going to have to answer in the form of maybe an exact answer of a natural log. So when we're calculating with natural logs, just like exponentials, it's a different way of remembering how it's done. So for instance, if we have y is equal to ln x, then the derivative of ln x is just going to be 1 on x. But you've got to remember that x has to be greater than 0. Okay, it can't be equal to 0, otherwise you have an undefined result. And if y is equal to ln and some other function of x, then the way we differentiate that is we have the derivative of f of x over the original f of x. Okay? On top of working with the natural logs and the derivatives, we have to remember all our rules. Okay, so our rules that we learned with logs still apply when it comes to working with derivatives of natural logs. Okay, so if you've got ln A plus ln B, well, that's the same as an ln A AB. If you've got ln A and B, you get ln A minus ln B. If you have ln B to the power of A, it can be rewritten as A ln B. ln 1, always going to give you 0. ln E, so remember an ln and a natural exponential will cancel out, so therefore you'll just get 1. And then the same thing happens if you have an ln e to the x, they'll cancel out, you're being given x. We are going to go through some examples today, and the examples up on the board here, and you'll be seeing ways that we can use some of these rules to help us solve questions. So, without further ado, let's get into them. Let's look at the first one here. Y is equal to ln 7x. Now, this here looks like this kind of calculation. Okay, and we're going to do it that way first, and then you're going to see that it won't really matter what value we've got in front of your x up here, you're going to get the same answer. So if we're looking at the derivative of this, dy dx is equal to, remember it's the derivative of this function. So it's 7 over the original function. Now if we simplify this, these should cancel out and I'll get 1 on x. And the reason why I wanted to show you this here is if you get something that looks like this, ln 7x, you're going to get 1 on x. ln 10x, you're going to get 1 on x. ln 1 million x, you're going to get 1 on x. Okay, so there's nothing wrong with going through this process because it's going to lead you to where you want to go anyway. So if you are inclined to like carrying calculations through, then do it this way. It follows the trend that we have. Okay, just know that you will be expected to simplify it down to this value here. Okay, let's have a look at the second one. So the second one is y is equal to 3 minus 2 ln x. So we look at this type of question here, this is different to what we had for our first one. It's not ln 2x, it's 2 ln x. So let's differentiate it. If we differentiate this here, we've got a constant, that's going to give me a 0. Okay, so therefore I have a 0 already. And now I'm looking at this part here. I'm going to have negative 2, but I'm going to times this here by the derivative of ln x. And I know the derivative of ln x is 1 on x. So, 1 on x. So therefore my final answer when I look at this here is negative 2 on x. Different to the 7x because we had the 2, but if you had something that looked like a 2 out the front, then you would have 2 on x again. Okay? So that's your final answer, negative 2 on x. Y is equal to x squared ln x. Now a lot of the times when it comes to working with natural logs, you're going to have to simplify it. Okay? And it makes life so much easier, especially when you do an application. And again, the questions will say simplify into an exact answer. So we know this here is a product rule. So we've got our u, we've got our v. So let's apply that rule. So u is x squared, u dash 2x, v is ln x, and then v dash is equal to 1 on x. So we know that we've got these types of calculations here. Let's now do our product rule. So remember, the product is the product of the inside plus the product of the outside. So dy dx is equal to 2x ln x plus x squared times 1 on x. Now we can cancel out one of our x's here, because this here is exactly the same thing as doing 2x ln x plus x squared on x. And using our indice rules, I can subtract this away and have that down to 1. So therefore our final answer would be 2x ln x plus x. And we do need to be able to get into these kind of simplifications. Leaving it like this, would that be acceptable? I'm going to say no, because you should be able at this level start simplifying it down. Okay. Let's look at our next example. Y is equal to ln x on 2x. Okay. So, in this example here, we've got a quotient rule. So, u is equal to ln x, u dash 1x, v is equal to 2x, and then v dash is equal to 2. So remembering, it's inside, product of the inside plus the product, minus the product of the outside, divided by the bottom squared. So we would have dy dx is equal to, we'll do 2x times 1 on x minus 2 ln x all over 2x all squared. So just like in the previous example question, we want to be able to simplify it off. And we know that the first one we can simplify is these two x's. Another thing that we can actually do is expand out our brackets down the bottom. Now we don't generally do this, but we're going to do this because we need to simplify this question. So we'll have 2 minus 2 ln x over 4x squared. What this allows me to do is it allows me now to simplify everything I have. I can now simplify this further. I know I'm going to get a 1 minus ln x all over 2x squared. And that's my final answer here. Okay, we've simplified it all the way down to what we need in the most simplest form. Again, makes life easier. We're not dealing with something like this where we've got some fractions. We're dealing just with some information that helps us substitute values in. Let's look at this next one. So we got y equals ln x to the squared. So let's treat it like it is. It's essentially a chain rule kind of question. So we've got dy dx is equal to 2 ln x times by 1 on x. And that's it. So we'll just now rewrite this here as 2 ln x over x. And we're not going to simplify this because we can't simplify x to cancel down our x's, so we don't go any further. Last one. So let's write the last one up. We've got y equals ln e to the x square root x. Now if we look at this question very carefully, it looks a little bit like this question just here. And you would think, I'm going to do the product rule of this question because I've got a product of two things. But what I want you to get your eyes towards is have a look at something that looks like this. This here is exactly the same kind of format that I've got written here. And I could do the product rule, but I'll be doing more work than I need to. And just remember, when you're working in questions and you're under exam conditions, you want to be able to answer the question with some more or exactness and under speed control. So we know that if this looks like this, I could rewrite it as two separate logarithms. Again, I'm not doing any derivatives just yet. I've got ln e to the x plus ln square root of the x. I'm not ready to do any derivatives just yet. And what I would say to you here is, don't differentiate a part of it before you're ready to do the whole lot. And the reason why is if you differentiate this and you get a value, and then you change this back down, you're going to differentiate this again, and then differentiate this differently. Okay, and therefore you may get the wrong answer. So get into a habit where you can differentiate the whole line together. So y is equal to ln e to the x plus ln x to a half. Let's look at this a little bit further. There's something else we can add to it. Have a look at your rules again. We've got on the left-hand side. What can I apply in both of these instances? Well, I know that ln e is just going to give me x. So I can rewrite this here as y is equal to x. If I look at this function here, this function looks something like my third rule, where I can bring my power down the front. So now I can say half ln x. And now I'm at a point where I'm ready to differentiate. I can differentiate now because I've simplified my function right down to where it needs to go. So therefore, what I would get here is dy dx is equal to, well, the derivative of x equals 1 plus half times 1 on x. So therefore my final answer here becomes 1 plus 1 on 2x. Okay, so when we're using logarithms, remember you've got these rules here for a reason. We didn't just teach them to you because we had to. We taught them to you because they can be used to simplify questions. Okay? And in this exact question here, we've used 3 of these rules. Okay? 1 rule, 2 rule, 3 rule to help us differentiate and get the correct answer. That leaves us with logarithms. It is a bit of a tough topic sometimes, but once you get used to the rules and understanding that there are different ways that you can use the log rules with your calculus rules, lots of rules, it does become a second nature to you. And another thing you need to remember when it comes to logarithms, we need to simplify as far as we can go. Okay? Because a lot of the times it's going to ask you to leave it in an exact form, and that exact form could be in terms of a natural log or an exponential. Good luck.